Hi all, welcome to Chandan English YouTube channel. Very good afternoon. Okay, before starting the session, once all of you click the like button. In this session, I am going to discuss chemistry topic, classification of elements and periodic table properties. So each and every students listen carefully from starting to ending. Okay, so each and every topic is very important from this concept. Okay, you will get at least 2 questions from this particular chapter. Okay students, so first I will explain the concept, then next I will display the question. If you know the answer, mention it in the comment section. What are the elements, how the elements are arranged, so how the scientists arranged, so on what basis they have arranged the elements, so what is Daubenier triad, so what is the law of octave, so these concepts we are going to discuss now. Okay, so each and every students listen properly. Why? Because you know the importance of like a periodic table and classification of elements. So you can see in every exam you will get one question from this concept. So what is the classification of elements, how it was done, so which scientist classified like elements, on what basis, on what factors they have classified these elements. So in this session we are going to discuss. Okay. Classification of elements and periodic tables in properties refers to the systematic arrangement of chemical elements. You know what are elements, right? So what is this classification of elements? Classification of elements is nothing but based on their chemical properties. So based on their chemical properties, the systematic arrangement of elements are arranged. So each scientist has done this classification based on certain factors. In this session we are going to discuss on what factors they have classified those elements. Okay. So in general we know what is periodic table. So we have modern periodic table, we have Mendeleev's periodic table. So each and everything we are going to discuss in detail. Okay. So we all know that as of now how many elements we have in periodic table? 118. Okay, the horizontal rows are known as what, students? Mention in the comment section. The horizontal rows are considered as periods and the vertical rows are known as what? Groups. So in total we have 18 groups and 7 periods. Okay, so each and everything we are going to discuss. Very good afternoon. Hi one and all. Hi Vamshi. Hi Pannuru. Okay, please share this video to your friends so that it will reach to maximum strength. So how many groups we have, students? We have 18 groups, we all know that. And how many periods we have? We have 7 periods. Okay. How many block of elements we have? S block elements, P block elements and D block elements and finally F block elements. Okay. S block elements, group 1 and group 2, group 1 and group 2 including hydrogen and helium. These are considered as what, students? S block elements. Okay, S block elements are also known as alkaline. Okay, alkane elements. Alkaline elements. Group 1 is known as alkane elements, alkali elements, and group 2 is known as alkali elements. Group 17 elements are known as halogens and group 18 are known as inert gases. You all know very well. So these are the basic things everybody knows. Okay. So as of now, how many elements we have, students? 118 elements. So these two orange colored or pink colored are considered as S block elements. Okay, S block elements. From group 3 to group 12. So group 3 to group 12 are considered as what, students? D block elements. D block elements are also known as transition metals. Okay, and F block elements are also known as what, students? Inner transition elements. And finally P block elements. Okay, so these are the SPDF block elements. Okay, next. Groups. How many groups we have? Actually, we have horizontal. So vertical columns. So this is a periodic table, right? So the vertical columns are considered as groups. In total, how many groups we have, students? In total, we have 18 groups. Okay. So group 1 elements are considered as alkali metals excluding hydrogen. Okay, group 1 elements. These group 1 elements are called as alkali metals excluding hydrogen. And group 2 elements, these group 2 elements are considered as alkaline earth metals and group 17 are considered as halogens and group 18 are considered as noble gases. Okay, everybody knows this, but in detail how these metals or non-metals or metalloids are arranged. According to what factors they have arranged, we are going to discuss in this session. Okay, so this is very important among all the groups, among all the 18 groups. Which are the 4 important groups to be remembered? Group 1 elements are considered as alkali metals. Group 2 elements are considered as alkaline metals, earth metals. Group 17 halogens and group 18 inert gases or noble gases. Okay, next, as I told you, the vertical columns. So the vertical columns are considered as what, students? Groups. So what are these horizontal columns? Horizontal columns are considered as periods. How many periods we have, students? 1, 2, 3, 4, 5, 6, 7 periods. Okay, we have 7 periods and 18 groups in periodic table. And how many number of elements we have in our periodic table? 118 as of now. As of 2026, how many elements are there in our periodic table? 118. Very important. Okay. So periods are nothing but the horizontal rows. Period 1. So this is very important thing. So remember, students, how many periods we have? In total we have 7 periods. So how to remember that? In period 1 we have 2 elements. In period 2 we have 8 elements. In period 3 we have 8 elements. In period 4 you have 18 elements. In period 5 you have 18 elements. In period 6 we have 32 and 32. This is very important. So remember these values. Period 1, actually what do you mean by period? The horizontal rows of the periodic table are considered as periods. In total, how many periods we have? We have 7 periods. Okay, how to remember this? How many elements are present in each period? So this is the basic thing to be remembered. 2, 8, 8, 18, 18, 32, 32. That means in period number 1 there are 2 elements. In period number 1 there are 2 elements. What are those? Hydrogen, helium. In period 2, there are 8 elements. In period 3, 18, 18, 18, 32, 32. Okay. So, period 1, these are shortest. Only 2 elements are present in this period 1. What are those? Hydrogen, helium. And in period 2 and 3, this consists of 8 elements each. In period 4 and 5, 18 elements. And period 6 and 7, very long. That means each period consists of 32 elements. They are nothing but F block series. Okay, F block series are what, students? Mention in the comment section, lactanates and antidates. So these are considered as what, students? F block series. This F block series each consists of 32 elements. Very important. Okay. Next, very good afternoon, Shivani, Vamshi, Pannuru. Okay. Next, till now we have discussed how how do we classify elements. So what are groups? How many elements we have in our periodic table? So how many groups we have, how many periods are there? So what are the important groups to be remembered and how the elements are arranged in the periods? Till now I have explained this concept. Okay. Next. So S block elements, I have told you already the first 2 periods. The first 2 periods are considered as, the first 2 groups are considered as S block elements. In a periodic table, the first 2 group elements are considered as S block elements. So, including plus helium and hydrogen. Okay, group 1 plus group 2. These 2 groups are considered as S block elements. Okay, including hydrogen and helium also. So, how they behave? These are mostly highly reactive electropositive metals except hydrogen and helium that are soft and have low metallic points. So, what are these, students? Group 1 and group 2 are of the periodic table, including hydrogen and helium are considered as what? S block elements. Okay. So, how they will behave? Okay, they will have high electropositivity, they will react, their reactivity will be very high, okay, and all these elements will have soft and low melting points. Okay, how their nature will be, how these S block elements will behave as, they have soft and very low melting points. Okay, very important, students. So what are this? What is this? S block elements. S block elements are nothing but group 1 and group 2 elements along with hydrogen and helium. So these are considered as S block elements. How they will behave? So they will have high electropositivity, that means they will easily gain the electrons, And not only that, except hydrogen and helium, all these elements will be very soft and these elements will have very low melting point. Okay, very important. So let us discuss some of the characteristics and some of the properties of these S block elements. Remember, this is very important table. Okay, the elements in which the last electron enters the s orbital. Okay, the element which enters the s orbital, we all know. So actually this is the nucleus. Okay, these are considered as what shell? These are considered as shells. Okay, these are considered as electron shells, and the last one is considered as what shells? Valence shell. The outermost shell is considered as valence shell, and the outermost electron is considered as what shells? Valence electron. So listen now. Okay, groups. How the groups are classified, how the groups are arranged means the group elements are arranged based on the valence electron. Okay, valence electron is nothing but the last outermost electron is considered as valence electron. The elements are arranged in groups based on its valence electron. In periods, so remember, in periods, the arrangement of electrons are arranged based on the electron shell. Electron shell are nothing but principal quantum number. Okay, principal quantum number is nothing but what shells? It is denoted by n. Okay, in periods, the elements are arranged based on the electron shell, and in groups the electrons are arranged based on the valence electron. Valence electron is nothing but the outermost valence shell electron is considered as valence electron. Okay, next. So what are the characteristics of these S block elements? How these S block elements characterized will be? Like they will have high reactive metals. That means they will be easily reacted with any other metals. The elements which are in S block, so they will easily reacted with any other metals. And not only that, they are soft and they have low ionization energy. The S block elements will be very soft and they will have very low melting point, and even they will have very low ionization energy. They are the good conductors of heat and electricity. S block elements are the good conductors of heat and electricity. Okay, so these are some of the flames. If we burn that particular S block elements, so which color flame will be occurred? So now we are going to discuss. Okay, if we burn the lithium, so what is the color of the flame? We will get crimson red. Okay, if we burn the sodium, we will get golden yellow, and if we burn the potassium, we will get the violet, and if we burn the calcium, we will get the brick red. If we burn the strontium, we will get crimson, and if we burn the barium, we will get the apple green. This is very important. So these type of questions were asked many times. Okay, if we burn the certain metal, so which color flame we will get? For example, if we burn the lithium, what color flame we will get, students? Like crimson red. In the similar way, if we burn the sodium, we will get golden yellow, and if we burn the potassium, we will get the violet. So this is very important table. Make a screenshot of it. And even we will get important compounds also. From these elements, from these S block elements, we will get some important compounds like common salt, caustic soda, washing soda, baking soda, quicklime, limestone, gypsum. So these are the important compounds belonging to these S block elements. Very important. Okay, next. So group 1 elements are called, as I told, alkali metals. So they form strong bases like NaOH, Na2CO3. These are all I have discussed. So group 2 elements are called as alkaline earth metals. Why I am only explaining group 1 and group 2 elements means these two are considered as S block elements. Okay, next. So P block elements. P block elements are nothing but the elements from group 13 to group 18. The elements from group 13 to group 18 are considered as what, students? P block elements. Next, elements include group 13, 14, 15, 16, 17 and 18. So these are also known as what, students? Boron family. This group 13 element in what? Noble gases. So carbon family. Which group is known as carbon family? All of you mention your answer in the comment section. Which group is known as carbon family? Okay, mention it in the comment section. Next, So D block and block. D block elements are considered as transition metals. They are from the group 3 to 12. Okay, group 1 and 2 S block, group 3 to 12 D block, group 13 to 18 P block, and F block are like which are downwards. Okay, like D block elements are also known as transition elements. They are from the group 3 to 12. Next, F block elements are considered as what? Inner transition elements. Okay, they are nothing but lanthanides and actinides. F block elements are considered as what, students? Lanthanides and actinides. Okay, this is very, very important. Notions: carbon family. Which group is considered as carbon family? Group 15 or group 18? Tell me, students. Which group is considered as like group 13 is considered as boron family, group 17 is considered as halogens, group 18 is considered as noble gases. Carbon family is group 15 or group 18? Tell me, students. Yes, very good, very good. Tell me the correct answer. Okay, next. So SSC GD 2026 special batch is available on our Chandan Loix app. SSC CGL complete course is also available on our Chandan Loix app. RRB NTPC special batch complete course is also available on our Chandan Loix app. SSC exam CGL, CHSL, CPO, GT, MTS, stenographer complete course is also available on our Chandan Loix app. Railway exam complete courses are also available on our Chandan Loix app. Bank exam complete courses are also available. Bank SSC RRB combo courses are also available. APPSC, TGPSC, SI constable courses are also available on our Chandan Loix app. UPSC CSAT complete course is also available. So next, historical genesis. I have told you already. So each and every scientist have classified the elements based on some other factors. So in detail we are going to discuss now. Okay, in detail we are going to discuss now. So how to write the electronic configuration, we will also discuss in the upcoming slides. Okay, for example, lithium. What is the atomic number of lithium, students? Hydrogen, helium, lithium. Okay, so how to write the electronic configuration of this lithium? Electronic configuration is nothing but 1s2, 2s2, next 1s2, 2s2, 3p1. In this manner we will write the electronic configuration. So like okay, 1s2, 2s1. So this is the way how to write the electronic configuration. Okay, so S block consists of 2 valence electrons, P block consists of 6 valence electrons, D block consists of 10 valence electrons, and F block consists of 14 valence electrons. You all know very well. Okay, in this manner we will fill the electrons. Next, so this is the historical genesis. So each and every scientist has classified the elements based on some other factors. For example, already in Daubernier triads. So in 1817, Daubernier. So what he has said, students? He has said that grouped elements in set of 3 where the middle element's atomic mass was roughly the average of the other 2. So one of the scientists, his name is Daubernier. He has brought up one triad. What do you mean by this triad, student? For example, so lithium, sodium and potassium. So he has discovered that the middle element's atomic mass was roughly the average of the other 2. This Daubernier triad has discovered that. What is that? Okay, not only this, chlorine, bromine, iodine. So he has discovered that the middle element's atomic mass will be equal to the average of the other 2 elements. So he has discovered this. Okay, but in most of the cases he have discovered the triads, only 3 triads, but it is not applicable to another elements. In this purpose, this triad was failed. Even though, like if you look at the chlorium and iodine, the atomic mass of this bromium is equal to the average of chlorine and iodine atomic masses. So this is the one who discovered this triad method, Daubernier triad. In which year? 1817. And the next person is Newland's law of actives. So Newland's law of actives, it was discovered in which year? In 1865. So what he discovered? He discovered that the element, for example, the element which is in the first position and the element which is in the 8th position, So these two elements will have the same physical and chemical properties. So who had discovered this thing? Newton's law of actives. He observed that every eighth element shared similar properties similar to musical notes. So how the musical notes will be there? The first rhythm will be similar to the eighth rhythm. In the same way, this Newland has discovered that the element which is in the first position and the element which is followed which is in the eighth position, these two elements will behave similarly. That means they have the same physical and chemical properties. But it is not applicable. This is applicable only up to 20 elements. The law which he has discovered, it is applicable only up to calcium itself. Then after, as we are going to higher elements, this law is not applicable. Okay? By this you can say that this law also failed. Next thing is Mendeleev's periodic law. So Mendeleev's periodic law was discovered in 1869. Remember students, each and every scientist discovery is very important. So first discovery was happened in like 1817. Who discovered this? Daubernier's triad. So what he has said students? Okay, so like a triad, what do you mean by triad? For example, lithium, sodium and potassium. The atomic mass of the middle element is equal to the average of the other two elements. So he has discovered this, but it was applicable only through the three triads. So he was not okay. And the next thing is Newland's law of actives. What he explained that, okay, the first element and the eighth element, these two elements will behave like they will have same physical and chemical properties. But this was applicable only up to calcium, up to element 20 only. Okay, and as we are going to the higher elements, this law is not applicable. And the next one is Mendeleev's period law. So Mendeleev's period law was discovered in 1869. Okay, so he proposed that properties are a periodic function of atomic weight. So what this Mendeleev's periodic table, he has arranged the atomic elements, he has arranged the elements based on the atomic weight of the element. This Mendeleev, how he has arranged the elements in a periodic table, he has arranged the elements based on the atomic weight. Okay, based on the arranged the elements in the periodic table. So the one which he does not discover, he left that place empty. For example, he famously left gaps for undiscovered elements like gallium and germanium. Okay, this Mendeleev's, this is one of the drawback. The undiscovered elements place were left by this Mendeleev. Okay, very important. Next, yes, group 14 carbon family. Yes, Vamshi. Next, so did you understand what are those scientist discoveries? Okay, so finally Mendeleev's 1869, he has arranged the elements based on the atomic weight, and the undiscovered elements gaps were left by this Mendeleev. So for example, which are the undiscovered elements by that time by Mendeleev? Example, gallium and germanium. And one more thing, this Mendeleev, he does not discover even noble gases also. At the time of 1869, Mendeleev has not yet discovered the noble gases like what are those? Argon, krypton, xenon. Okay, he does not discover that noble gases also. Next, modern periodic table. And finally, the thing which we are using as of now is modern periodic table. So it was brought up by which scientist, students? Henry Moseley in 1983. Okay, so he has arranged the elements based on the atomic number. Remember students, very important. So Daubernier, he has discovered triads. Newlands, he has discovered law of actives. And finally, Mendeleev's, he has discovered the periodic table based on the atomic weight. And finally, in 1913, Henry Moseley, he has arranged the elements based on the atomic number. Very important. Okay, the key thing is very important. Next, atomic number is, we all know that number of protons. What do you mean by atomic mass, students? Number of protons plus neutron is considered as atomic mass. What do you mean by atomic number? Just number of protons. Okay, it is a more fundamental property than atomic mass. This led to the modern periodic table. So these last states that based on the physical and chemical properties of elements. So very, very important. And the modern periodic table which we are using as of now was discovered by Henry Moseley in 1913. So based on what factors he has arranged the elements, students? Based on the atomic number. Atomic number is nothing but the number of protons present in an element. Okay, and based on the physical and chemical properties of the element, he has arranged the elements in the periodic table. The modern periodic table is organized into groups and periods. The one which we are seeing or which we are using the periodic table is nothing but this modern periodic table. He has arranged the periodic table into 18 groups and 7 periods. Who is that person? Henry Moseley. Okay, periodicity in properties such as atomic radii, ionization, enthalpy, electronegativity and metallic character shows recurring patterns across periods and down groups. Okay, next. Okay, very good, very good. Next, so need for classification of elements. So what is the need? Actually, they have classified the elements, that's okay. What is the need to classify that elements? We are now going to discuss. Okay. While researchers identify only a few dozen substances by the mid-19th century, the modern catalog has expanded to 118 unique elements. Okay, did you understand? By the mid-19th century, only a dozen of elements were discovered. So as of now, how many elements were discovered, students? 118 unique elements were discovered. Very, very important. Okay, include attempting to memorize the individual behavior and chemical compounds of every single element is mathematically and properly impossible. So remembering each and everything, is it possible to remember? No. Okay, is it possible to remember each and every element? So it is in which group, it is in which period, is it possible? No. For this purpose only, the elements were classified into particular groups and periods. Did you understand? What is the need to classify the elements, students? So, as we are having 118 elements, it is not possible to remember each and every elements. So, based on the chemical and physical properties, if we divide those elements into groups and periods, we can easily remember them. For that purpose only, these elements were classified into groups and periods. That is the need for this. Okay. Next. Consequently, classification serves as an essential tool for simplifying the study of chemistry through structured characterization. Did you understand what I said? In order to simplify, in order to memorize the things, so these periodic table were classified into groups and periods so that we can easily remember. For example, group 18 elements. So these are considered as halogens. So okay, we can easily memorize. So what will be in group 18 elements? Halogens. Okay, fluorine, chlorine, bromine. Sorry. Okay, what are in xenon, krypton, argon, xenon, krypton, helium. These are considered as what, students? Noble gases. Okay, so what are halogen, fluorine, chlorine, bromine. In this way, if we give a particular name to a particular group, we can easily memorize. For this purpose only, the elements were classified into groups and periods. Next. Factor, which factor? Atomic weight or atomic mass. He has classified the elements into periodic table. Dmitry Mendeleev represents the first recognizable periodic table to the Russian Chemical Society on March 16, 1869. Okay? Okay, in 1869 he has discovered this periodic table. So, he formulated the periodic law stating that the properties of chemical elements are periodic function of their atomic weight. Just remember, on what basis Mendeleev has brought up the periodic table, on what factor, on what basis? Atomic weight. Just remember this. Okay, and Henry Moseley, on what factors or on what basis he have discovered the modern periodic table? By considering the atomic mass, atomic number. Just remember. Okay. So, what are the drawbacks of this Mendeleev's? Let us discuss. Okay, Mendeleev has discovered only 63 known elements. Remember, students, he has discovered the periodic table in 1869 based on atomic weight. So at that time, he has discovered only 63 known elements, and the things which were not discovered by him, he has left that gap. Okay. Mendeleev arranged the 63 known elements in order of increasing atomic mass. Okay. Based on the increasing of atomic mass, he has arranged the elements which were known to him, 63 elements as the increasing order of atomic mass. For example, if atomic mass of helium is 2, example I am saying, if the atomic mass of helium is 2, he has arranged the element first. In the increasing order, he has arranged the elements. Who is that person? Mendeleev. On what factors? On the increase of atomic mass. Next, left gaps. Okay, I have already told you, Mendeleev has left the gaps for undiscovered elements. So, what are those undiscovered elements? Eka aluminium, that means gallium, scandium, germanium. So, these were not known to the Mendeleev at that time. So, the gaps were left by him. By whom? Mendeleev. So, they are also known as Eka aluminium, Eka boron, Eka silicium. Eka means what, students? That means they behave similar to the germanium. For example, Eka aluminium. These Eka aluminium, these have the same properties of gallium. So, they behave same as gallium. For that purpose, he has left the gaps for those things. Next, anomalies over. He prioritized chemical similarity over strict mass order. For example, okay, he placed iodine after the tellurium. This is very, very important. Okay, so how he placed, how he arranged the elements means, for example, iodine. What is the atomic mass of iodine? Atomic mass of iodine is 127. So why he placed iodine after tellurium means, why? Because the iodine and tellurium, these both have the similar which is approximate equal atomic mass. For example, iodine atomic mass is 127, tellurium atomic mass is 128. So, these are approximately equal. For this purpose, he has placed iodine and tellurium side by side. Okay. Based on what factors he has arranged the elements? Based on the atomic mass. Okay. If the atomic mass of one is 2 and if the atomic mass of one thing is 4, so he has arranged down by down. In the similar way, he has arranged iodine 127 first, then after he has arranged tellurium the next. Why? Because iodine atomic mass is 127 and tellurium atomic mass is 128. So, he has arranged down by down. In a similar way, better match those of the halogens fluorine, chlorine, bromine. So, the 1869 version was oriented differently. It had 17 columns and elements with similar properties. Okay. So, it was not known until 1871 vision that the table adopted. So, these are not that important. Okay. Next. So, what are the limitations? Okay, Mendeleev's time periodic table. What are the limitations? I have told you already. Mendeleev has not yet discovered group 18 elements. Sorry. Okay, he has not discovered noble gases. Very, very important. In the Mendeleev periodic table, he has not yet discovered the noble gases. Noble gases are nothing but group 18. Okay, helium, neon and other noble gases were entirely unknown and omitted by this Mendeleev. Very, very important. These were the limitations of the 1869 Mendeleev periodic table. Helium, neon and other noble gases were not known to him. In the similar way, this Mendeleev has do not know where to position the hydrogen. This is also one of the important limitation. Okay, this Mendeleev does not know where to position the hydrogen. Hydrogen is the first element, right? In the periodic table, which is the first element? Hydrogen. But Mendeleev does not know where to position that hydrogen. This is one of the drawback of this Mendeleev time period. In the similar way, we all know what are the isotopes of hydrogen, students, like deuterium, tritium, protium. So, these are the isotopes. Okay. What do you mean by isotope? Isotopes, they have the same number of protons but different number of neutrons. Okay. So, at that time, that Mendeleev has not yet discovered the isotopes too. So, these are the three limitations of Mendeleev's. So, once again I am discussing, students. Okay, once again I am discussing what are the limitations of this 1869 Mendeleev's periodic table. This Mendeleev, he has not yet discovered the group 18 elements. That means helium, helium, argon, xenon. Okay, helium, argon, xenon, krypton. These are the noble gases. He has not yet discovered and even omitted them. And he has not arranged, he has not positioned the first element, hydrogen. And the next thing, he has not yet discovered the isotopes. So these are the limitations of the Mendeleev 1869 periodic table. Okay, next. So now we are going to discuss MCQs. Okay, till now we have discovered, so what is a periodic table, how are the classifications made, what are groups, what are periods. So different scientists, how they have classified, on what basis they have classified the periodic table elements, we have discussed now. And now we are going to discuss MCQs based on this concept, so which are very, very important and which are PYQs. Okay. So each and every students, mention your answers in the comment section. How many elements are officially recognized in the modern periodic table as of 2026? 100, 118, 120, 150. Yes, tell me students, what is the answer for this question? Each and every students, mention your answer in the comment section. As of 2026, how many elements are arranged in periodic table? The periodic table which we are using and which we accepted is known as what? Modern periodic table, and that was given by Henry Moseley in 1913, right? So in that periodic table, as of now, how many elements were there? 118, very good. Okay. Next, elements in the same group have the same number of what? Protons, neutrons, valence electrons, electron shell. So as I told you already, how the groups and periods are classified. Groups, okay, the elements having the same number of valence electrons, so they are arranged in the same group. Listen properly students, even though if you had not listened to my previous, just now joined in the session, you can easily answer to my question. I will even explain each and everything in detail. Okay, so I have already told you what I have told you. As of now, we have 118 elements. How the groups and periods are arranged? So the elements which are having the same number of valence electrons, though these elements are arranged in the same group. The elements which are having the same electron shell, those are arranged in the same period. Okay. Now tell me the answer for this question students. Very good. The elements which are having the same group have the same number of valence electrons. That means the group 1 elements, these group 1 elements have same number of valence electrons. For this purpose, this group 1 elements, all those are arranged in the group 1. A group 2 elements, so these group 2 elements are also having the same number of valence electron. I have already told you what do you mean by valence electron. Valence electron is nothing but the outermost shell electron is considered as valence electron. Okay, next. Which group is known as alkali metals excluding hydrogen? Group 1, group 2, group 17, group 18. So tell me students, I think everybody will answer to the question which I am displaying. The questions which I am displaying on the blackboard, so these questions are very, very important students, and these are from PYQs, previous year's questions also. Okay, so what is the answer for this question? Very good. Okay, I have told you already, group 1 elements are considered as alkali metals, group 2 are considered as alkaline earth metals, group 17 are considered as halogens, group 18 are considered as noble gases. Okay, remember students, among all those 18 groups, these 4 groups you must remember for sure. Group 1. The period number corresponds to the number of what in an element's electrons? Valence shell, electron shell, protons, neutrons. So I think everybody will answer to this question also. Okay, I have told you already, group work. Based on what factors group elements are arranged? Based on the valence electron. In the similar way, based on what factors the similar periods are, the similar elements are arranged in the period? So tell me. Yes. Each and every students, please mention your answers in the comment section, and not only these class students. So before this class, we have many sessions on general science. You can go to that sessions also. Very good, Naruto. So based on the electron shells, the elements are arranged in the same period. If the elements of a same period, okay, how the elements are arranged in a period, if that elements are having same electron shells are nothing but having higher principal quantum number. If the elements are having higher principal quantum number or energy levels, that are considered as electron shell. Okay, based on what factors, elements are arranged in the same period, based on the electron shells. Just remember the key point. Srikanth, actually this is completely English medium channel. Okay, so I have to explain the concept in English language only. So if you need classes in Telugu language, you have a Chandan Telugu YouTube channel, so you can check those sessions. Next, how many elements are in period 1? So tell me students, I have even given you the trick for this also. How many elements are there in period 1? How many elements are there in period 1? I have even given you the example, trick for this also. Tell me students. Okay, 2, 8, 8, 18, 18, 32, 32. So period 1, period 2, period 3, period 4, period 5, period 6, period 7. So this is the trick to be remembered. Okay, in total how many periods we have students? Periods are nothing but horizontal rows. Okay, in total we have 7 horizontal rows. So period 1 consists of 2 elements, that is hydrogen, helium. Period 2, 18, period 3, sorry, period 2, 8, period 3, 8, period 4, 18, period 5, 18, period 6 and period 7, 32. So if you remember this values, you can easily answer. So now tell me students, how many elements are in period 1? Very good, 2. S block includes which groups along with helium and hydrogen? Group 3 and 4, group 1 and 2, group 13 and 16, group 17 and 18. So tell me students, I have already told you S block consists of which 2 groups including hydrogen and helium? Wait a minute. So tell me students, S block consists of which 2 groups? Very good, very good. So for SSC, GD, RRB, NTPC, so the basics questions will be asked like these questions only. So which group elements are called as alkali metals? Which group elements are called as halogens? So these type of basics questions will be asked. Okay. So tell me students, what is the answer for this question? Very good. Group 1 elements are called as alkali metals. Group 2 elements are called as alkaline earth metals. So these two, group 1 and group 2, along with hydrogen and helium, they are considered as S block elements. So how the characteristics of these S block elements will be there students? Remember, except hydrogen and helium, these these S block elements, they will be very soft. They are very soft and they have very low melting point. Okay, and they have very low ionization energy and they will be highly reactive to any other metals. Okay, very good, very good. Next, characteristics of S block elements include being highly reactive and what? Hard and high melting point, soft and low melting point, non-metallic inert. Just now I have discussed how the S block elements will behave. Okay, the S block elements, they are highly reactive, they have very low ionization energy, so they even form the important compounds, they are good conductors of heat and electricity. And how they will be? Tell me students, just now I have discussed about this concept, how the S block elements will be. Very good, they are soft and have low melting points. D block elements are also known as what? Transition metals, inner transition metals, halogens, noble gases. Very good students, very good. D block elements. D block elements means from group 3 to group 12. Okay, in the periodic table from group 3 to group 12. So these are considered as what, students? D block elements. So they have other name also. So D power 10. They have 10 valence electrons. Okay, now tell me the answer for this question, students. Very good. Transition metals, and inner transition metals means F block. Halogens means group 17. Noble gases means group 18. Very good. Next, B, inner transition metals is for F block. Okay. Next, in D block elements, the differentiating electron enters which orbital? N minus 2 into F, N minus 1 into D, Ns, Np. So these are the electronic configuration of S. S block elements electronic configuration is Ns, and P block is Np, D block is N minus 1 into D, and F block is N minus 1 into F. So this is the electronic configuration. Okay. For example, what is the atomic number of sodium? Atomic number of sodium is 11. Okay, how we will write this? 1s2, 2s2, 1s2, 2s2, 3p6, 4s1. Okay, in this way we will write. Yes. F block elements include which series? Lanthanides and actinides, alkali and earth metals, halogens and noble gases, transition metals. So tell me, students, F block elements. Okay, F block elements consist of what? We have already discussed group 1 alkali metals, group 2 alkaline earth metals, group 17 halogens, group 13 boron family, group 14 carbon family, group 15 oxygen family, group 16 oxygen family, group 17 halogens, group 18 noble gases. F block elements are what? They are also known as inner transition metals and also having lanthanides and alkanides. So these two are considered as S block elements. Halogen and noble means group 17 and group 18. Transition metals means group D, D block. Next, Daubeney's triad were group of how many elements? 2, 3, 4, 8. I have already explained about this triad also. Triad is nothing but, for example, chlorine, bromine and iodine. Okay. For this triad, what happens, students? The atomic weight of the atomic mass of the bromine, okay, the atomic mass of the bromine will be equal to the average of the atomic mass of the chlorine and iodine. So these are nothing but what, students? Triads. Who had discovered this Daubeney triad. Okay. So what is the answer for this question? 3. Very good. Newland's law of actives compared elements to what? Colors, musical notes, shapes, numbers. So what do you mean by this Newland's law of actives? Newland's law of actives is nothing but the first element and the 8th element, or the 8th element and the 16th element. So these two elements will have the same physical and chemical properties. So it was given by whom, students? Newland's law of actives. Okay. So he compared this law of actives to what? Tell me. Musical notes. Very good. Mendeleev's periodic law stated properties or periodic function of what? Atomic number, atomic weight, electron configuration, valence. So tell me, students. Very good, very good. So I have told you already, Mendeleev periodic table, which was brought up in 1869. He has discovered almost 63 known elements, and the undiscovered elements gaps were left by Mendeleev. Okay, example, gallium, scandium. So these were the undiscovered elements by Mendeleev. He has not even discovered the noble gases also, and he has not positioned the hydrogen position also, Mendeleev. Okay, so on what factors he has arranged the elements? So tell me, students. Very good on atomic weight. Very good. Okay. Next, Henry Moseley discovered that atomic number is more fundamental than what? Atomic mass, electron shells, valence electrons, protons. Okay, modern periodic table which was discovered by Henry Moseley in 1913. He has discovered that, okay, he has discovered based on atomic number, the arrangement of elements in periodic table will be more efficient when compared to what? So that was explained by Mendeleev. So tell me students, this is also atomic mass. Very good. Okay, what this Moseley has told students, he has said that, so based on atomic number, the arrangement of elements will be more proper if we do it by considering atomic number. Okay, very good. Yes. Next, modern periodic table states properties or periodic functions of what? Atomic weights, atomic number, electron orbitals, group number. So just now we have discussed. So tell me students, so just remember, so what to be remembered in this unit? So just what is periodic table? As of now 118 elements. So in group we have 18 groups, in periods we have 7 periods, okay, and we have 4 blocks, S block, P block, D block, F block. Okay, left side are considered as S block, right side are considered as P block, and the middle one are D and F block. So just remember these things. Okay. Next, Daubeney, he has discovered the triad. Newland, he has discovered the law of octaves, and this Mendeleev, he has discovered only 63 elements. What are the limitations? He has not yet discovered the noble gases. He has not positioned the hydrogen. He has not yet discovered the isotopes. And the next thing, now as of now we are using modern periodic table. It was discovered in 1913 by Henry Moseley. Okay, so these are some things. Very good. Based on atomic number. Okay, atomic number, very good. Next, by mid-19th century, how many substances were identified? A few dozen, 118, hundreds, thousands. By mid-19. By mid-19, how many elements were arranged? By mid-19th century means 1869. It's around hundreds. Okay. A few dozen. Okay. In 1913, 118. Okay. Next, Mendeleev presented his table in which year? 1817, 1865, 1869, 1913. Mendeleev has brought up his periodic table in which year? So tell me students. Each and every student mention your answer in the comment section. Daily I am conducting live classes in Chandan Loic's English YouTube channel and in Chandan Loic's Telugu YouTube channel also. Today's evening session I am going to conduct a live session on Mughal dynasty. Okay, so yesterday I have gone up with Bhakti and Sufi movement, and today I am going with Mughal dynasty. Each and every student, so attend those Indian history series also in Chandan Loic's Telugu YouTube channel. 1869. How many known elements did Mendeleev arrange? 63, 118, 32, 18. So Mendeleev have discovered how many known elements in his periodic table? So tell me students. Yes. Look at the question properly. How many elements, how many known elements did Mendeleev arrange in periodic table based on atomic weight? Yeah, very good, 63. Mendeleev left gaps for undiscovered elements like what? Helium, gallium, iron, uranium. Okay, he has discovered 63 known metals, and he have arranged in the periodic table. Okay, and the elements which were undiscovered by him, the gaps were left by him. So in the given 4 options, which is the one which has left a gap for that element? So tell me students. Very good, gallium. Eka aluminium is known as gallium. Gallium, scandium. So those are the undiscovered elements by Mendeleev, he has left gaps for those things. Very good. Very good. Eka, aluminium, scandium, germanium. So those things were undiscovered by Mendeleev. In Mendeleev's table, he placed iodine after tellurium due to what? Atomic mass, chemical similarity, atomic number, electronic configuration. I have told you already, atomic mass of iodine is 127, atomic mass of tellurium is 128. Based on what factors he have arranged the iodine and tellurium side by side? Based on what? So in order, like iodine, chlorine, bromine. So in order to come these things like in a same row, he has arranged the iodine beside tellurium. Why? Because those two elements have the same chemical properties. Very good. Assertion. Elements in the same period have the same number of electron shell. Periodic number corresponding to the highest principal quantum number. So as I told you, so tell me students, this is the assertion and reason. I have told you at the beginning of the session itself, based on what factors the elements of the same group will be in the same group? Based on valence electron. Okay, based on what factors in the elements will be arranged in the same period? Based on the electron shell. Electron shelling is nothing but high principal quantum number. That is nothing but energy levels. So now tell me students, is the assertion and reasons both are correct? If they are correct, so mention your answer in the comment section. Very good. Assertion. S-block elements are mostly highly reactive elements. They have low melting point and are electropositive. So so tell me the answer for this question. Even I have explained about this one also. So S-block elements, these S-block elements are nothing but group 1, group 2 along with hydrogen and helium. Okay, they are having very good conductors of heat and electricity. They are having very low ionization energy. They are very soft, except hydrogen and helium. They are very soft and they have very low melting point. Okay, even they form some important compounds like NaCl, okay, caustic soda, washing soda. These are some of the compounds from S-block elements. Now tell me students, what is the answer for this question? Very good. Mendeleev's table had no place for noble gases. Noble gases were known in 1869. So tell me the answer for this question. Yes. Yes. So there are some limitations for Mendeleev time period. Okay, Mendeleev's periodic table, there was some limitation. Actually, Mendeleev has discovered the periodic table. At that time, he has discovered only 63 known elements, but he has not yet discovered the noble gases and not yet discovered the position of the hydrogen and not yet discovered the isotopes. Okay, so tell me the answer for this question. Very good. Why? Because noble gases were unknown in 1869. The noble gases were known in which year? I think in 1871 or 1898. Okay, so both A and A are correct and R is the correct explanation of A. Which of the following is incorrectly paired? D block, group 3 to 12, F block, lanthanides and actinides, S block, group 1 and 2, helium, hydrogen, period 6 and 7, 1896. So guess the answer and tell me the answer for this question, students. So identify the incorrect pair and mention your answer in the comment section. And tomorrow I am going to discuss like a biology topic, nutrition and nutrients. Very, very interesting and important topic. Okay. What is the answer for this question? Identify the incorrect pair and mention your answer in the comment section. Very good students. Why? Because, so as we all know, 2, 8, 8, 18, 18, 32, 32. The period 6 and 7 will have 32 elements each, but they have given 4. If they have given 4 and 5, this will be correct. Okay? Very good. Very good, Sharma. Very good, Joseph. Next. Which of the following is incorrectly paired? Daubernier triad, Newland's octaves, Mendeleev atomic number, Moseley atomic number. So now guess the answer and tell me, students. instead of reading chemistry in depth, if you know the concept, it is enough. Okay, so instead of reading it in very depth way and forgetting, that is not a good manner. What is the answer for this question, students? (23, 24, 25). So answer for this question is Mendeleev. Why? Because Mendeleev has classified the elements based on the atomic weight or mass, but he has given atomic number. Okay, very good. SSC GD special batch complete course is available on our Chandan Loix app. SSC GGL complete course is also available on our Chandan Loix app. RRB NTPC special batch complete course CBT1 and CBT2 complete course is available on Chandan Loix app. SSC exams 2026 CGL, CHSL, CPO, GD, MTS training of complete courses are also available on Chandan Loix app. Railway exam complete courses are also available. Bank exams complete courses are also available on our Chandan Loix app. Bank SSC RRB combo courses are also available. APPSC, TGPSC, SI constable courses are also available. UPSC CSAT complete course is also available on Chandan Loix app. Okay, so each and every course were explained both in English as well as Telugu languages. We have 3 channels, Chandan Loix, Telugu, English and main channel. Please subscribe to those 3 channels so that if there is any live session, you will get a notification. According to that, you can join in the live session. In the evening session, I am going to conduct live session on Mughal dynasty, Indian history point of view. So each and every student attend to that class also. Okay, bye students, take care. Let's meet in the evening session.